Hello, this is G. Ramesh Kriya, Assistant Professor, SNS Course Technology, Department of Computer Science and Engineering. So the course name is 19 CST 302 Neural Networks and Deep Learning. The topic is Vanishing Gradient Problem. So, vanishing gradient problem is a process or a phenomenon that occurs during the training of deep neural networks, and the gradients that are used to update the network become extremely small or vanish as they like back propagated from the output layers to the earlier layers. So during the training process of the neural network, the goal is to minimize loss function by adjusting the weights of the network, and this back propagation algorithm calculates these gradients by producing the errors and by process of the error from the output layer to the input layer. So vanishing gradient problem. So this is a process or a phenomenon that occurs during the training of deep neural networks. That is during the deep neural networks when the gradients are being updated in the network. So when the gradients are being updated, the network become extremely small in size, or in some cases it may vanish. So when they back propagated from the output layers to the earliest, that is to the front layers. So this process is known as the vanishing gradient problem. So during this process, the goal is to minimize the loss function by adjusting the weights of the network. So the consequences of vanishing gradient problem include slow convergence, network getting stuck in low minima, and impaired learning of deep representations. So if a model is suffering from vanishing gradient problem, we could just figure it out using the following types, or following, we could call following symptoms also. So the parameters of the high layers change to a great extent, while the parameters of the lower layers barely change or do not change at all. And so the parameters of the higher layers change to a great extent, while the parameters of lower layers barely change or do not change at all. So the model weights could become zero during the training process. The model learns at a particular slow pace, and the training could occur at a very early phase and after only a few iterations. So these are the symptoms like. So what is the reason for vanishing gradient problem? Is the vanishing gradient problem is caused by the fact that the process of back propagation goes on. The gradient of the early layers, that is the layers that are nearest to the input layer, are derived by multiplying the gradients of the later layers. So the layers that are near the output layer. So that is gradient of the early layers. So early layers are the layers that nearest to the input layer, and later layers are the layers that are near to the output layer. So therefore, if gradients are later layers or less than there, multiplication vanishes at the particular rapid pace. So why is the vanishing gradient problem significant? So the vanishing gradient problem is significant. That is, it causes the gradients to shrink. So as we saw previously, the size reduces rapidly. So it causes gradients to shrink. But if a gradient is small, it wouldn't be possible to effectively update the weights and biases of the initial layers with each training session. These initial layers are vital for recognizing the core elements of the input data. So if their weights or biases are not properly updated, it is then that the entire network could be inaccurate. So how to overcome this vanishing gradient problem? So there are several ways by which we could overcome this vanishing gradient problem. The first one is by using residual neural networks, ResNets. Second one is multi-level hierarchy. Third one is by using long short-term memory, LSTM. Fourth one is using RDLE, that is rectified linear units, and the next one is like batch normalization, and we are following other ways like weight initialization, gradient clipping, and skip connections, gate architecture, reduced network depth, and faster hardware. So these are some of the ways by which vanishing gradient problem can be overcome. Thank you.